Guys, and in this video we're going to be creating our first neural network using Brain.js. So this is going to be a really cool video, so let's get right into it. The first thing we need to do is get the link of our CVM so we can actually use Brain.js. Now, in simpler terms, what we're doing is we're just importing Brain.js as well as installing it. So this is how you do it. I will put this in the description so you guys can see it. Anyways, that's it for our index.html page or HTML, so we can go to our JavaScript. Now, what we're going to be doing is we're going to be doing something called exclusive OR. This is saying that if two inputs are the same, our output is 0. And if two inputs are different, then our output is 1. Now, you can read more on exclusive OR in the description. I'll give you a link to that. But I'm not going to cover too much on it in this vid. So let's feed this to our model. The first thing we need to do is actually create our model, right? If we want to feed anything to it, we need an actual model. So how we do that is we just create a variable and have create a new brain neural network. All right, so this neural network will have 3 hidden layers because we have 4 layers. So 3 hidden layers. And if you guys do not know what hidden layers are or don't know how neural networks work, you can check out my video in the description, which basically is talking about TensorFlow and telling you what a neural network is, right? So you can check that out before coming to this video or watching this video, so you just have a better understanding on what a neural network is. Anyways, after this, to feed the data to our neural network, we say net. Wait, let me call this network. So network dot train, and then we can feed this data. So, all right, finally we can run this. So we can just print out what our output is, and that would be network dot run, and then we have to give our input, so we can just say 0, 0 right now. And you can see it runs, and it gives us 0.05867421254515648, right? I know I said that. But anyways, the reason why this is just not 0 is because the neural network can't give the exact number yet, but as long as it's fairly close, we know it's right? So this is 0, right? It is 0 at least. And then 0.0, and then 586. So it's 0.5 off, right? And that's good. So that's how we know it works. And let's say we feed it a 1 there. You can see it has a number fairly close to 1. So 9. Okay, I'm not even going to read it. Anyways, that's about it for this video. Thank you guys for watching. See you in the next one. Guys, so in the last video, we created our first client-side Brain.js neural network. We did this using 4 main steps. Number 1, creating our actual data. This data is composed of all the main rules of exclusive OR. Our second step that we used was instantiating our neural network, or creating our neural network. The third step that we did was training our neural network with the data that we created in our first step. And finally, our fourth step was just running our neural network with our inputs. Now, even though on the outside it may seem pretty simple, on the inside it's a bit more complicated. So in this video, I want to show you guys what's happening in these last 2 steps. Alright, training and running. In this video, we'll be talking about back propagation and forward propagation. Alright, let's get started. I'm going to show you guys these models on Paint. I am using my computer for these models, so they're not great. If you guys have trouble reading them, just send me an email or put it in the comments, and I will try to make you a video explaining it better. All right. So let's say that we have a basketball. All right. And I'm going to make this orange. And this basketball, we're trying to shoot into a hoop. Okay. So let's make this hoop right here. Now, let's say that we're at three-pointer. For those of you guys who know how to play basketball. So that we're a three-pointer. So this line is three-pointer. And three-pointer is 20 feet away from the hoop. All right. So it's pretty far. And for someone who hasn't played basketball before, you guys probably don't know how much pressure, how much force you need to put into the ball to go into the hoop. Right? Now, this is the same idea for a neural network. When you create a neural network, it's like a baby. It doesn't know anything. And its idea is to learn, right? So for someone who doesn't know how to play basketball or never played basketball before, it's like a neural network that's trying to do this. All right, I mean, obviously, much different, but same idea. Now, the first thing you probably are going to think about is how much force you need to put in the ball, right? Not worrying about how much angle, how much, not really worrying about trying to get the ball into the hoop, mostly trying to just predict how far you need to throw it, right? So that is our first step. That's what forward propagation is. Forward propagation is just the process of predicting. Okay? Now, let's say you came a little short and the ball landed right here. All right, it landed at 17 feet, let's say. All right, now what happens is we can take this prediction and we can actually measure it, right? That's what I just did. I just measured. And this step is back propagation. All right, this is the first part in back propagation. It's just taking that measurement or taking that value and doing something with it. All right, and this comes to our next step of back propagation. This is doing something with it, using that info and actually doing something with it. Now, if we see that it's 17 feet, then we know that we need to put 3 more feet to get to our hoop, right? And maybe we can make another prediction that is a little bit more force. And we can keep improvising and adding these final touches, little touches, one by one, till eventually we score, right? Or it doesn't have to score, right? As long as it gets pretty close to your, very, very close to your hoop or your final product, that's great, right? And one thing that you can know is a neural network can never be perfect. We talked about that in the last vid. When we saw that when we ran the program, it gave us not 1, not 0, but a number pretty close. All right, so you can see here, it's giving us 0.3402. I'm not going to read it. But as we keep training it, the model can get closer and closer and closer till it eventually can get 0.999999 repeated. right? But we can never get 1. That's just something that you need to keep in mind. So that's basically forward and back propagation, right? Now we can move on to our next step, which is running the program. So you can see here network.run, and we have our input values and output values. Now when we're running our neural network, we already know how far we are from our goal, or how much force that we really need to put, right? Because we've already gone through our back propagation. And in this whole propagation stage, in this whole training stage, we have this measurement. We have our measurement, right? This measurement is what we call our error, all right? And as a neural network runs, we want to decrease, we can change our error and decrease our error rate, right? And we can actually see this error in the function, right? So how we do this is we can actually log it out. So just follow with me here. Log error, right? So you want to log our error. It's already built in. Log error, and we want to console.log it. All right, and let's say our log period is 100. All right, so now what this is going to do, a log period is not defined. All right, we don't need a log period. All right, so I'm going to close this all up. Now when we run this, you can see it actually prints out all our logs, all our log periods. And you can see this number is constantly decreasing. All right, so I don't know if you can see it, but we have a lot of log iterations. So just we didn't put a period till we get 0.005039. In our first iteration, we had 0.2. So our training error, we were like 20% off, 25% off, right? And here we're less than 0.5 off, right? So you can see this massive decrease. All right, so that's what I'm talking about. The neural network is constantly getting better and better till we have a very, very low error rate. And you can see it here. If we go down, this is lower than the last one. All right, so let's remember this. 0.050316. All right, so write that down. 0.050316. All right. Now let's run this again. And we get 0. Sorry, 1 second. We get 0.050219. Our last one was 0.050316. So we can actually see that we did get better. And you can see as this keeps going, we decrease our error rate till practically 0, almost 0. I mean, it can never be 0, but very, 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 very low. Okay, so it went from 0.25 to 0.0052. So that's a big improvement, especially on this level. So you can see as you keep going, it should keep getting better. And yeah, so you guys can play around with that, try to see how much it's getting better. But again, that's it for this video. And my name is Pranav. See you in the next one. Alright. So in this vid, what we're going to be doing is we're going to be creating a neural network that is more user-friendly than our last neural network. Our last neural network didn't really give us that much text or string. It was mostly all numbers. And it wasn't very user-friendly. In this vid, we're going to try to make a neural network that is at least a little more user-friendly. And we'll be using strings to accomplish this. It's basically the same idea, but does require some extra steps. So let's get started. So I have this data, and it's essentially just saying the best movie for that day, or best movie theater for that day. And it could be prices, things like that, but it's just saying the best movie theater for that day, based on the prices for the movies. And we'll try to take this data and feed it to the neural network so it can give you an output based on what day you enter. All right, so first we need to feed this data to our trained data, which is a list. All right, so let's create our training data. And to do this, we will need a for loop. All right, so, all right, guys. Now, what we're gonna do is I'm just gonna tell you what this is, what it is basically explaining, and then we'll move on to the next step. All right, so basically, this is just saying that the day of the week is equal to the index of the movie name. All right, so whatever you enter is equal to the index of the movie name. So because this is equal to this, basically if you enter life movies, that index is the movie name. All right, so now what we want to do is we just want to push this data as our input and output to our training data. So our input day of the week is 1, and our movie name is 1. So that's really simple. That's a pretty simple line of code. And just take some time to just scan that and understand it. Now what we want to do is we want to actually create our neural network. So let's do that. So if you guys remember, we just need a constant, and we can call this network. And basically you type new brain.neural network. Brain.neural network. I hope I typed that correctly. And inside you put the hidden layers. So these hidden layers, we'll say we have 3 here. And we also have this. Alright, so we need our right here. Alright, now let's just train this. So network.train, and then with our training data. And finally, let's run this. So let's actually, I think console.log would be better for this type of data. run. Do you want to run this? And let's give it an input of Monday. So you want movies and snacks, and we'll give that as 1, right? Because so it's giving us that training data is not defined, and that's because I just spelled it like this wrong. All right. So now when we run this project, let me bring the console up. You can see we get this list or this array, and it's basically just giving us the values of each movie. So what it thinks. So this is pretty nice. It gives us the prediction. So it thinks movies and snacks is 89%, Pranav's movies 52%, life movies almost 0%, so 0.000000065, movies fun run 0052, and popcorn movies 0.072. So we can clearly see that movies and snacks is what it guessed, and that's correct. So now maybe let's try to make it where it only gives us one value instead of all these values. So let's also have a for loop, or we'll just put right here let's say 1 right here. All right. I think that should, all right. Right now, never mind. But anyways, we can see, so I guess the project worked. And yeah, that's great. Thanks for watching this video. See you in the next one. Alright guys, so in this video we're going to be talking about how to count with a neural network. Now, most of us watching this video know how to count, right? 1, 2, 3, 4. But chances are you didn't know how to count when you were born. And someone had to teach you to be able to do that. Alright? And same thing with this neural network. A neural network is like a baby. It doesn't know anything, and we have to train it to do this. So even though the simple task of finding out the next number in an order, counting, the neural network has no clue how to do. So we need to train it and teach it how to do this. Alright? So let's get started. I'm going to use my paint to talk about some vocab we need to use to create this project, right? I mean, we don't really need it, but it's good to know going forward. Alright, the first thing we talk about is what a frame is. Alright? A frame is a width and a height. Alright? So, if you guys have watched a movie at the theaters or just at your house, a frame is just one picture or one picture, I guess, image in the movie. Now, how it shows motion is because these images are going so fast, it seems like motion is happening. And I'm not a pro motion scientist, that's what they call it, or pro animator, but I know that a frame is a width plus a height. Now, a frame's width and height is constant. Alright? So you just need to keep that. And these rules can be broken, but you don't see your screen going smaller and bigger every day. Now, we need to talk about something called depth. Now, depth is just multiple frames. Depth is context. Depth is amazing, right? Could have thought of a better word, but depth is what the final product, the movie, right? So depth, we'll just write this here. And this is like the context, right? So just keep that in mind, all right? Now, context or depth will repeat or occur. And something that recurs is recurrent, right? So I guess we can all agree that depth repeats because frames repeat, or they keep repeating, right? At least their width and their height. So depth is never the same in every movie. If one is 1 hour and 1 millisecond and one is 1 hour flat, the depth isn't the same, right? So just keep that in mind. And depth can also be putting together frames or values and giving an expected, or I guess value that wraps it all up, I guess. So if I give you A, B, and C, the depth could be giving D, right? Or not depth, recurrence would be giving D. So just keep that in mind because we will be talking about that. And if I just give you A, you guys probably don't know what you would do with A. And so we need some context to back that up. So B and C will probably give you D, right? Following the pattern. So if we go in the counting example, if I give you 1, 2, and 3, the output should be a number close to 4. Alright, so let's get started. Now there's 4 main steps in every neural network that we do in Brain.js. First, give the data. Alright, second, create the model. Third, train the model. And fourth, run the model. Alright, so let's get started following these 4 steps. Alright, so first we need to give the data. So our data will be what sequence it is. And let's start off easy with add 1. Alright, so just regular counting, 1, 2, 3, 4. So our training data, and this is not going to be some fancy array or list. It's just going to be a simple 1-line list. So training data is 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we'll give it 0 for now. Actually, not 0. We'll just leave it like that. And this is just all the numbers in our that we can count right now. So we'll just use this. It seems that we have an error. So let's try to fix it up. I got this equal sign. Yeah. All right. Our next step is creating your model. So this is probably the only different step. So just stick with me here. The const network constant, and it equals a new brain. And most of us would just carry on with neural network and then give our hidden layers, right? And the last few times is 3. But in this case, we're creating a recurrent network. So we put dot recurrent instead. Right? Now, follow along with me. Dot LSTM timestamp or timestamp, sorry. Okay. Now, LSTM is long short-term memory, and timestamp is basically the process of guessing the new number. So it's kind of like our depth. Now, let's just train the model. So network, this is just the regular network dot train, and then we'll feed our training data. And now let's run it. So console.log network.run, and inside we'll give the sequence. So if we say 3, 4, 4, 3, 4, let's see if we can get a 5, or a number close to 5. Oh, and we get 1.7869. It seems that we haven't gave, or no, wait, 6. We have 6. It seems we haven't gave enough data, right? So let's just put our 5 here, and now it should think. Or what's happening? Seems like it's a glitch. Okay, and it gives us 5. Okay, I think that's. Oh, look at our list. It's totally messed up. I did not see this. If you guys were like, why is it? Oh my god, this is funny. Okay. So our list was just a little messed up, and this should give us a number close to 5. Or let's try to give a full sequence. So you can see it's not working. Well, I mean, it is working, but it's not giving good accuracy. All right, so let's say 1, 2, 3, 4, 5, 6, and I think this is enough. My computer isn't that fast today. Should take some time. Sorry, guys. And we get 6.998. So there you go. Our neural network has worked. As I said in the last few videos, your neural network can never be perfect. So if we get a 6.9, we know that's a dub, because 6.999999999 repeated is the highest we can get. So as we train our model, it should get better and better. But anyways, you guys can play around with that. You can actually do reverse order. I guess that's my challenge for you guys. So if you guys can make a reverse order one and send me this, if you have a Scrimba or something else, if you just send me it, that'd be great. So thank you guys for watching this video. My name is Pranav. See you in the next one. Alright, guys. So in this video, we're going to be talking about normalization. Now, this should be our final product after this video. We're going to basically convert this data into binary, or data that a computer can understand. So let's get started. So I'm going to delete this code so we can have a blank start. And normalization can be split into 2 parts, right? Normalization is the process of converting something that's not normal to something that is normal. So, for example, let's say that your best friend, came up to you as you guys were walking to school, and he started talking in a language called dog that only dogs can understand. Now, this is obviously not normal, right? This is obviously not normal. Your friend doesn't speak to you in dog normally. So what we need to do is we need to make this normal, right? We need to convert it into proper English that we can understand. And this process is normalization. And that's not the best example, but we can use that and kind of see how this relates to computers. I have this data, and this data is just the IPO of a stock, the high of a stock, the low of the stock, and the closing price of the stock. All right, so this would be the high price, low price, closing price, and opening price. Now, why am I just throwing this random data at you? This is because in the next video we're going to be actually creating a stock price predictor. So I just wanted to use this example for now. All right, so now this is pretty big numbers. 141, 171, 152, 138. And this is not normal for a computer. A computer speaks binary, and binary are composed of zeros and ones. So giving this data will take the computer a long time to understand, just like you would take a long time to understand your friend who's speaking dog. So let's try to convert this data just with a simple function to make this data zeros and ones. All right, and this is a very logical function, so let's get started. So as I said, this process is called normalization. So let's call this function normal. All right, normal. And this function should do a number of things. It should divide each of these data, or each of these data. It's not correct grammar. Each one of this data into ones and zeros. So how would we do this? Take a moment to try to think of this before I explain it to you guys. All right. So if we want to divide all this data into ones and zeros, the easiest way to do this is to take the lowest data value and divide all the values by it. Because if we were to divide every single one of these with its value, we'll get 1 for each of these. And if 1 is the value for each of these, that's not very accurate, right? So let's divide all of these values by the lowest value. So this lowest value would be 1. All right? And this value would be 1 point something, 1 point something, 1 point something. So let's get started. All right, so we're going to pass through this probably like TS for timestamp, just so we can use this to divide. Right, so open is equal to TS or timestamp dot open divided by 138. And that's pretty simple line of code. So we can just copy and paste this 4 times and see how this works. So we'll call this one's high, this one's low, this one's close, right? And we just need to convert this one too. So high, right? This one low, and this one close. Okay. So now we have a syntax error. Let's solve that before we keep going on. And this error is saying that it has an unexpected token, and it expected a semicolon. So this is just, we just have to return this, and it will work. So just return this, because it doesn't really know what to do with it. So let's return it, and our error is gone. All right. So now what we want to do is, this is our normalization function, right? And let's just test this out, right? It's already done its work, but now we actually need to do something with it. So let's store a variable. All right. Var, we'll call it NF for normalization finished, equals, we want to pass normal. All right, we want to pass normal, and we want to pass raw data into this normal. So what this is going to do is it's going to just pass this string into this normal function, and we'll get our output. So raw data, and we want to pass the first one. All right, so that's it. And now let's just print this out. So semicolon, and now we'll just say console.log NF. Right. So let's see how this works. And you can see it actually prints all these values. So we have 1.02, we have 1.24, we have 1, and we have 1.10. So this is pretty simple data for our computers to understand. So just before we leave, let's look at how to convert this back. So really all we have to do is do the opposite of dividing, and that is multiplying. What did I do? All right. So it seems that we have an error, I guess. All right, I just copy and paste this wrong. So now what we can do is we can multiply this, and also let's pass 1 through there. So unexpected token, I guess that's not a figure that we need to worry about yet. So TS1, and we'll open here. And actually, we don't need any of this. All we need to do is we just need to multiply this back. So instead of times, we multiply. So now let's run this NF through our normalize function. So console.log normal, and we'll run this TF with that. Oh, TF is not, oh, NF, sorry. NF. And, we have this times that much. I guess I had to put this as a constant before. Don't know why I didn't do that. So first we need to convert this back. It's funny how this is such a simple thing, and it's taking me more than the actual project. All right, so you have that. And this is dividing again. So I'm going to call this a var for now. Var. And then I'll pass it through here. Okay, this is just weird. I don't know what's happening. All right. Anyways, now what we need to do is, so there, guys. My brain is not working properly today. Basically, so we just need to write this function again. Call this normal one. Multiply this. All right. Seems that we have an error, but it's all right. Don't think that's that big of a deal. And let's just change TS1 to, just so we know how to differentiate. And now let's first have a constant called TF, And this will be equal to normal, just how we just did that, normal, and we'll pass our raw data. Right, and console.log this. And now what we want to do is we want to convert this back. So also we want to console.log normal 1, and inside this we'll put our normal normal so you go like this. I think I put 1 before my normal, just like that. Okay, so let's run this. Normal is not defined. Should be defined. Oh my god, it was a matter of indenting. Wow. Normal is not defined. That's normal 1. Okay. Perfect. Let's run this. And you can see we get our data back. So let's put our console. Oh my god. What's happening today? Console. And you can see this is that data and we've converted back. So this video took a lot more time than I thought it should, or that it should have. But anyways, thank you guys for watching this video. My name is Pranav. See you in the next one. So in this video, we're going to be creating our stock price predictor neural network. And I have tweaked a few things, so I want to show you those before we get started. So the first thing I did was I got back our scale up function because we are going to use it. And the next thing I did was I basically got this data from the BrainJS documentation to use for this project, right? So our last data would not work because, not that it wouldn't work, it was just not accurate. It wasn't like the actual data for this. So I just got this data so we can actually do this project. So let's get started. Now, I went ahead and I actually formed our training data by just converting our raw data into binary and then just incrementing it into, or putting it into our training data by increments of 5. Now what we want to do is we want to create a model. So we will be creating our recurrent model. If you guys remember, in 2 videos ago, we created our counter, and that's what we're going to be using. So brain.recurrent lstmt time step. All right, so we got this down, and we'll say our input size is 4, and our hidden layers are 8 by 8. I think so, but if it's wrong, then we can edit it later. Yeah, I'm pretty sure this is an 8 by 8 array. So I'll give you the BrainJS documentation in the chat so you guys can, or not the chat, in the description so you guys can look at that. And our output size is also 4. Now what we want to do is we just want to train it. So we're putting our learning thresh and an error thresh. So it's going to train until an error of 0.02. I mean, I guess we can make this lower if you guys want, or we don't even need an error thresh if we don't want to, but learning thresh, learning rate, I'm probably going to put a limit so it doesn't like overlearn and go on forever. So I guess that's it for creating our model. So now let's just run our model. So console.log, and we're going to pass our scale up. So right now it is in the binary scale down form. So for us to read it, we need to pass it through scale up. And now network.run, and then we'll put our training data. All right, so that should be it. And let's run to see how it goes. I know this was a fast video, but yeah, we have our output here. And we have a I would say absurd output. So let's see what went wrong. We have 96 and 99 when our data is in the 100s, really, right? I mean, I guess this is its prediction. So I guess when we keep running, it should get better. Well, let's just check our code just in case we miss something that is causing it to have this weird. All right, so now I guess it's better. So I guess it's correct, but like it just needs some training. So you guys can see we have our neural network and it's working pretty good. So yeah, so thank you guys for watching this video. And hope to see you in the next one. So I'm sorry what I did in the last video. I just forgot one small step that gave us the absurd output. So we just had to put our first value key. So we put this. We just need to insert 0 here. I'm so sorry. I don't know why I forgot about that. But anyways, see you in the next one. Alright guys, so in this video, we're going to be creating a neural network that can essentially read. Now, this is probably going to be our easiest neural network yet, probably other than our second one, second one. But I do feel that this is pretty straightforward and it is our coolest neural network yet. So essentially what this is going to do is the neural network is going to try to find the next phrase matching up with the phrase that you give. For example, if I say the ride home, I don't know why I said if I say or something like that. But anyways, if I give the neural network the ride home, it should give me, or our expected output in a few runs of training was an awkward one, right? So, I mean, in elementary school, this is really kind of what we're doing, right? I mean, personally, I'm in 5th grade right now, so I know this is what we're doing in school. I mean, maybe a little more advanced, but something like this, right? We have some context clues, we have a passage, and we're basically trying to take that passage and answer some questions on it. And this is kind of saying the same thing. So, for example, if I say, what was the ride home? Or, I mean, that's kind of a bad example. Let's say Bob is, let me add some text here, is nice. Okay. If I say, what is Bob? Or if I say Bob, then the neural network should say is nice. And you might just think that, or some people maybe when you just look at it, you're just like, oh, well, I don't really see what this is doing. I mean, I feel this one's even more straightforward than the last ones. I mean, I feel like the last ones were kind of a little bit complex if you don't think about that the neural network is actually doing the work and it's not just the data there. But if you're just saying, well, obviously just saying the next phrase after. Well, how does it know the next phrase after? And put your get in this neural network shoes. Not literally. How would a neural network, or I mean, just logically speaking, right? How would you think a neural network would find the next phrase, right? Like, how would it know that was an awkward one is the next phrase? We're not giving any other data. And I know, like, we should be giving any other data, right? How is it just doing this randomly and out of 4 lines of code once we're done? Well, I will have an intermediate course on client-side JavaScript, BrainJS, and neural networks. That's a handful. Where I'll talk about all these built-in functions. Not all these, yeah, all these functions in BrainJS. All right, so like, sure, right? Maybe if it was just taking the next word, then it should just split it up, or just logically looking at it, it might just split it up by space, right? Space. But if I give it like the, it's not going to just give me right. It's going to give me like whatever it thinks it should be. So you'll see how that works. But for now, just know that you can put any text in here that you'd like. Just make sure it's not too big because it might take a long time for the neural network to run. All right. So now all we need to do is just create our network, and that's pretty simple, right? We're just going to create a recurrent network, not a timestamp, nothing. Just so simple. I don't even know. Again, couldn't find a rhyme for that. I don't even know how. Well, actually, I do, but yeah, I think you know what I mean. So essentially, we don't even need a time step here. It's just we need a recurrent number, right? Because we're dealing with strings and not numbers. And now what we want to do is we want to, if you guys hear a little bit of background noise, I'm sorry, that's just probably my family. Next thing we need to do is we just need to train our network. And in our last projects, at least our last networks, for example, this one, we didn't really specify or some data values, or we didn't really specify in specific our iterations in Airthresh, right? And the reason for that is this is actually a really simple neural network, right? It's cool, but it's simple. It's a very easy pattern, right? I mean, even though if you put yourself in the neural network shoes, which is not literally speaking, I mean, obviously, if it's like a newborn baby, then it's tough. A newborn baby doesn't know what 1 and 2 is, but obviously there's built-in functions after this inside these functions. So, but this is a pretty simple pattern, like 1, 2, 3, 4. All of you guys know to say 5, right? But this is a bit different, right? As I talked about earlier, this logically looking at this, there's no pattern that a neural network can follow. And even though a neural network is modeled after the brain, the neural network does not work like a brain. All right? I have a course on that, on kind of how the neural networks work, called like TensorFlow, how do neural networks work. But so you can learn a little on there. But they cannot see, or technically can, but they are not nearly as complex as our brain. They're very complex, but not nearly as complex as our brain, right? And a neural network is not just a brain in a computer. Okay, most people already know that, right? When it looks at an image, when you look at a cat, how do you know that it's a cat? Just pause the video and answer me that, right? How do you know that it's a cat? How can you say in a split second, oh, look at that cat over there? Well, you might have an image of a cat before, and you're just like, your neuron fires up, and you're like, well, that's a cat, right? Obviously, not a doctor. But this neural network, it's looking at every single pixel, and it's looking at the differences and similarities in the pixels, right? And obviously I talked about the string. So now, I actually forgot what my point was. It's kind of embarrassing. I forgot what my point was. But basically, I'm just saying that your neural network, I think goes to this text, right? Your neural network does not know English, right? a neural network does not know English. So, or doesn't know how people write and all these forms of English, right? So, kind of crazy how it knows stuff. And I know that was a handful of stuff just for this one small point. But I hope I tried to make it more sense. I think I just made it more complicated. Sorry, guys. But anyways, I just want to tell you that this is some really complex stuff that the neural network is doing. It's kind of crazy how simple it is. So we'll talk about that. There's built-in functions in another video. Great. So, anyways, I think I was going forward to say that your neural network, to do this. Oh, yeah. All right. So to do this, it's not nearly as simple as counting, right? Because counting, it's a very simple pattern, as I talked about, and this there is no patterns, as I also talked about. Right. So that's what I want to say. So let's just give some iterations in Airthresh just so we can look at our neural networks training and we can get better and better and better. All right. So I know that was a handful of stuff. So yeah, I hope you guys aren't more confused. If you guys are more confused, that was just, I don't know why I said that, but sometimes it just like just go on saying anything. So I'm sorry for that. If you guys by any chance got more confused by what I was saying, just put that in the comments and I'll try to make it more I'll try to make like a separate video or something, or send you an email with an explanation, right? So but anyways, just don't really worry about what I just said. If you guys understood it more, that's great. If you guys do not understand it more, well, that's okay. And if you guys went down with what I was saying, then please send me an email because I do not want that to happen. All right. Anyways, so we got our training data, and finally, let's run the project. So log compile.log net dot run, and then finally the ride, because I think I talked about that earlier. All right, so I think we're connected with our HTML. If it spits out a number, then we're connected to index 1, but spits out some words, then we're great. So it will take some time. I will be telling you that because there's a lot of work. So if it's this page unresponsive, that is a normal thing. Just wait. All right. And we got an unexpected error rate. So I want to run that again because I did not expect something like that to happen. So let's see what happens. Oh, actually, I'm just gonna open my console. I don't know why I run that. So it seems we have an unexpected error rate. What is our error rate? Oh, okay. I guess that was just an error in the code. So the code is right, the syntax is right. I don't know why I just get there. But anyways, you can see you got this text. So home was an awkward one. Lena and George were scolding loud now as if he just burned down the house. And if you guys are interested in actually reading this writing, just put the comments in below, and I'll send you guys it in the description. But enough of that. Home was an awkward one. Lena and George were scolding loud as if he just burned the house. So I feel that was a pretty good first start, right? At least we got this part, and Lena and George are scolding. Now we kind of want to take this part off. So let's run it again and see if we can get a better output. going to take some time, so just stay with me. And yeah, so while it's going, I just want to talk to you guys about the next video. So the next video in this series is going to actually be the last video, I think. And what we're going to do is we're going to take my Magneto text. So this is an app that I built, and it's pretty simple. It's kind of just like Google Docs, I guess. It's basically just a text editor, and we're going to be combining it with this neural network, and we're going to add a stage to it that allows you to have, there's like a model button or something, and it's like read. Yeah, it'll have like a read, and then it'll actually look into the text and do this. So I think that's going to be a really cool video. So stay tuned. Stay tuned. Alina House. All right. So I don't think it did have any improvement. Their house. Actually, last time it said down, I think, or something like that. But as you run it, you'll see that it gets better. You can change this air thresh and iterations if you'd like to make it even better. But anyways, I know this video was longer than expected, but thank you guys for watching this video. Thank you for sticking through. The next video will be the last one, so stay tuned. I will have more neural network videos like this. So thank you guys for watching. My name is Pranav. See you in the next one. Guys, so in this video, we're going to be taking our neural network that we created last video, and we're going to be incorporating it or putting it into one of my websites, Magneto Text. Magneto Text is basically a text editor. It can do a lot of things, the basic things, and now we're going to take it a step further and make neural network projects with it, right? So now it's not just a regular old boring network or regular old boring text editor. It's a regular old boring text editor that can perform neural networks. So it's not boring anymore. It's a cool text editor that can perform neural networks, right? So that was a handful, but I think you got the point. So I want to show you guys that we can actually take our neural networks and we can put them into websites so we can share them with the world. Right? So, and that was the reason why I created this course. And I didn't just stop at Python. I wanted to keep going so we can incorporate our networks with our projects or our websites and share them with the world. If you guys whatsoever have no HTML, CSS knowledge, and you just got at JavaScript, then I do have some courses for you guys on my YouTube channel. I think I do have one I created a few months ago called HTML course, or I think it was like the icon was like web development, something like that. So you guys can check that video out. I will put that in the description. So let's get started. So I got my GitHub repository here, and with all this code, I will try to make a video with for this app because I do think it's very useful. I use this every single day, and I think you guys can create your own projects and use them yourself, right? I personally feel that it's really cool when you're using your own projects. Yeah, so let's get started. So I got this code, and what we just want to do is we just want to create a new button, right? So I'm hoping all of you guys are familiar with HTML, CSS, and JavaScript. If not, it's all right. Well, obviously JavaScript you have to be, but HTML, CSS, that's all right. Most of these things are pretty straightforward. So what we want to do is you just want to create a new button, and please, guys, you guys do not need to follow along with this. You guys can, if you guys have watched if you guys have created your own text editor, you guys can kind of do the same thing. Or if you guys are going to watch my video that I haven't created yet, but you guys are probably watching this video far into the future, and now it's still I don't know, October 15th. So by the time you're watching this video, that video will already be out. So you guys can check that out and maybe even do that before you get into this video. All right, so let's create a new button. And that's pretty simple. I'm actually going to create a drop-down button, which is something like this. So it's like a button that has multiple buttons inside. And so I'm just going to copy this and I'm going to put it in. You guys do not need to know any of this code or this design. This is just my design. So mostly this HTML part you guys don't need to worry about, but I will really appreciate if you guys watch this full video so you guys can see how this is going to work. Or you guys can just skip to the end of the video where we're going to actually use our webpage for this. So, yeah, so that'll be in the description. Sometimes my voice sounds like that. I don't know why it's like that. It just like randomly goes like that. So, yeah, so just sorry for that. So now we're just going to call this model. And we are going to just have one right now because that's the only really text one that we have. And this is just going to we're going to call this like reading or just read. And this is just going to be context or something, text clues. And maybe I'll create a demo on how to use this on like the website later. So if you guys are actually using this website, great. So you guys will probably already know about this, and it'd be cool to watch how this actually was happened. So I haven't actually made this before. So this is the video where I'm actually putting it on. So that's pretty neat. So I think that's it for that. So just make sure that's lowercase. Let's move on. But I do want to just take out this href. All right, let's get started. Now we're all familiar with the JavaScript page, so let's go to our JavaScript and just create our function. So I think I called it read, right? So function read, and then we'll just put our code here, and yeah, so I'm gonna put that code here, and I think what we're gonna want is, so this text, it should be entered. I mean, no, this text should be all the text in your text area, right? So I'm gonna delete all this text and just say in here document dot get element by ID demo, because that's what it's called in here, and then dot value. All right, so I think that should work. And now this should just be a prompt. So prompt, and then I'll say what should I call this? Maybe like enter phrase before. Or yeah, enter phrase. I'm just gonna say that because we're probably gonna create a demo on the video to show how this works. All right, so this is updated, so we just got to reload our page till it updates. Oh, it already updated, so that's great. So I'm just gonna actually put like actual text here. So yeah, so I'm just gonna take this text, put it there, because all right, whatever. All right, so now let's just just make it a bit bigger so you guys can see. I think that's it that we need. So model, context clues. All right. Did we get an error? Read is not defined. Did I not create that? Oh, wait. I lost the GitHub page. I thought it created the read, right? Wait, no, that's not where it. I thought I created the read. Maybe I forgot to call it read, or I didn't call it read. That's probably what happened. So yeah, I called it read. Oh, indenting. I thought JavaScript doesn't care about indenting. Guess I was wrong. And I also spelled prompt wrong, so let's fix that before we get there. So what's this indenting? Never had this weird indenting. Like this is like 4 or 5 spaces for indenting. I usually use 2, so that's why prompt that. And maybe I did that wrong. Function read, right? Let's see what the error was though. Oh, why would I go back? Okay, this was kind of a weird thing I just did. Yeah, so yes, model, context clues. Yeah, it's not. Oh wait. Oh no, it did run. Brain is not defined. Oh yeah, I have to just put that in there. That makes sense. Why would it be defined, right? Index. Okay, I hope that's worked. That code worked. It should have, right? So, that's not how that's gonna work. Okay, so it's all right. So, running this again, we may get some errors because it probably hasn't reloaded yet. So, yeah, that's probably it. Read is not again. Oh. I reload my page. Okay, let me check this text again. Read is not defined. Hey, wait, I mean, it is. I think, yeah. I didn't do the function right, so. Actually, I did. I don't know what went wrong. Because this function is perfect. So, read is not defined. Maybe I didn't link it. Did I link it to text.js? Yeah. I didn't. Yeah, I did. So, I do not actually know what went wrong there. Let's try to run it again. Maybe it'll help, I guess. Okay, something went wrong. If it does redefine, I have literally no clue what's going to go on. So, it didn't. Let's go. Now my page is froze, and it's unresponsive, which is a great sign because that means our neural network is working. Enter phrase, the ride, right? That's what we wanted. And let's look at our console. Let's go! Our neural network did work. That's amazing. That's great. Let's go. Now we just probably want to maybe make it a little bit better. So how about we just like alert this, because most people don't know what the console is. Or not most people. If you're not a coder, you probably don't know what the console is. So no one's gonna look there to see the answer. So let's just reload this. But that's amazing, right? Now we know that it works. So that's great. Now let's just run this project and see how it goes. So model context clues. All right, great. So we have that. It's amazing, and we probably want to like say something like, obviously we're gonna put the finishing touches, or I'm gonna put the finishing touches after the video. But you guys can put as many finishing touches as you want, or whatever finishing touches you want. Well, I do wonder something. I do wonder if it is still saving the data. I mean, it should, right? Logically speaking. Oh, it's still constant. All right, well, that'll go. I will create a video with the demo of this, so if you just want to share that with someone privately. But yeah, so that's it for this video. Thank you guys for watching. Alright guys, so thank you guys for watching this video. I put a lot of time and effort into this video, so I really appreciate the people who watch the video fully and learn from it, right? Because this is what it's all about. I hope you guys check out all the links in the description. Most of those things are there to help you throughout this course. If you guys have any questions, comments, or want to learn something new, please put it in the comments down below, or just email me on my email, right? So as always, stay safe, and I look forward to see you guys in the next video. Anyways, my name is Pranav. Peace.